Hello students, hope you all are doing well. So here in this video, we are going to take a look at the reactions of S-block elements with dinitrogen, its N2 gas. We are going to find that out the reactions of those nitrogen showing with S-block elements, S-block metals. First group, second group, S-block metals. In our earlier video, we have found out, revealed the secret behind all the S-block elements. Could you remember it? That it's all the S-block elements exhibit the same action during reaction. It's losing of electrons. They all lose electrons if they do react. I emphasize that fact. If they do react only. If they do react, first group elements they lose 1 electron, second group elements they lose 2 electrons. So it is lithium, sodium, potassium, rubidium, cesium, francium you have under first group, beryllium, magnesium, calcium, strontium, barium, radium you have under second group. Then we are going to take a look at their reaction with nitrogen, N2 gas. So you need to heat them as to check whether the reaction is having enough energy, activation energy. So let's heat those elements. Let's heat them enough as to make them react with nitrogen gas. Okay. Then here it's those S-block elements, if they do react, they would lose electrons. First group elements would lose 1 electron, forming unipositive cations. Second group elements form dipositive cations, losing 2 electrons. Then if there is a reaction only this is having, so then it's nitrogen is the only other party needs to gain all these electrons. There is no other species there. Then students, it's nitrogen need to gain these electrons as to form a negatively charged ion. What's the ion? It's N3 minus. N3 minus. So nitrogen is a second period element. So forming N3 minus, it's a highly negative, this charge, and it's having a high charge density there. So this high negative charge, this high charge density needs an opponent, needs a cation, opposite charge species to be with, to form a compound with. So to form an ionic bond with. Then the other one who is coming there to form an ionic bond with this N3 minus means the other species going to take the control of this N3 minus, going to form a compound with N3 minus, needs to be eligible, needs to have a greater charge density. There also that ion too needs to have a greater charge density, otherwise it can't. So it's the cations they form, all the first group elements, the cations they form are unipositive. Then it's quite simple, not enough the charge, it's unipositive. Anyway, down the group, its size, radius would get increased. With increase of the radius, their charge density would get decreased. So then they would not be eligible to control that high negative charge. Means their stability is going to get decreased. So these first group elements, nitrides, are not that stable. Down the group, their stability going get drop, decrease. Anyway, the top one is having a very small, means it is a very small, is having very small radius. Therefore, it would barely be able to control that. It would be able to form a stable nitride. Its lithium only get past this test, this ability of maintaining a stable nitride. Okay, all the other first group elements nitrides are unstable except lithium nitride, so they do not form their nitride. They refuse. We can't form a stable nitride, so we can't react with nitrogen. They do not react with nitrogen. Those first group elements, except lithium, having a considerably small radius, it exhibits some sort of ability, a talent. It would show a reaction with nitrogen, dinitrogen. When you heat lithium with nitrogen, you would get lithium nitride. Then, down the second group, their radius also would get increased, but all these second group element students would be forming their dipositive cations. So, their radii compared to first group elements would be quite less, small. So, then their charge density would be quite enough to form stable metal nitride with nitride ion. They all would form nitrides, so you would get their nitrides: beryllium nitride, magnesium nitride, calcium nitride, strontium nitride, barium nitride, and radium acid. So you would get stable nitrides being formed by those second group elements and lithium. Therefore, those only could react with nitrogen when you heat those elements with nitrogen. When you balance them, you could find here 2, 6. When you balance these, you could find here 3, 3, 3, 3, 3, 3. So that's the reaction that those exhibit with nitrogen gas. So it is again the point, it's only lithium in the first group would form a stable metal nitride. Others do not form a stable metal nitride, therefore those can't react with nitrogen. So down the second group, though their radii going to get increased, they all could form stable nitrides. So they all react. They all form their respective metal nitride reacting with nitrogen gas when you heat them with nitrogen. Okay, that's what the reaction. This is very, very important when you learn the reactions of ammonia. Ammonia with S-block elements as well. For the reason they form their nitrides only if their nitrides are stable. Others who can't form a stable nitride, you will find them not forming stable, not going to stable their metal nitrides, but ending the reaction with amides. Let's find that out in the next video. Anyway, students, it's very, very important, this thing, this fact, this basic thing. If you know this point, this logic behind the reaction of nitrides with S-block elements, if you could use this as to find out the products possible, they are in future reactions as well. Not by hearting those reactions, you would easily understand how to give the product, how to produce the product at the moment as the answer in the answer script. It's you do not need to by heart hereafter anymore. Realize this fact. Those who form stable nitrides only would react with nitrogen. Others for the reason that they can't form a stable nitride, they will not react with nitrogen. So in the first group, only lithium would react with nitrogen, others in the first group, except lithium, can't react with nitrogen. All the elements in the second group could react with nitrogen, forming metal nitride. That's why the summary. Okay, hope you could understand these few points, and there's a logic behind that. So you capture the logic, you understand the logic, then you will find how easy, how smoothly it's going, how thrilling finding out of products using logics, applying logics. Then you would easily realize these all. You would find chemistry as the easiest subject out of all. Okay, enough, right? Talking of those, it's not an overwhelming. It's the truth. You realize this, as then you would find that the point as you would easily find out the possible products. Logically find out the possible product. So here students, it's with that we are going to round up here. So we are going to find you in the next video talking the reactions of S-block elements with ammonia. Okay, till then, bye.